Welcome learners. Welcome to today's session. I am Dr. Neha, Seth, working in the capacity of Associate Professor with School of Management Studies at Indira Gandhi National Open University. And today I am going to continue a session on capital budgeting. There was one more session which already held on capital budgeting is available on the link which is visible on your screens. So this is the link on which the first part of this session is available, and today we are going to continue with this another session on capital budgeting. So in previous session, just to have a glimpse over it, in previous session we talked about capital budgeting, its meaning, its features, why it is importance of capital budgeting. We also talked about evaluation criteria, and we talked about that how evaluation criteria is categorized as non-discounting cash flow methods and discounting cash flow methods. We also discussed non-discounting cash flow methods, that is payback period method and accounting rate of return. We also learned to solve numerical problems for these two methods. And in today's session, we are going to talk about discounted cash flow methods, that is net present value, internal rate of return and profitability index. So without wasting time, let us start and talk about what are these discounted cash flows methods. Among these, the first one is net present value. So this is the most widely used capital budgeting method, and from the examination point of view also, this particular method, NPV and IRR, these two methods are very, very important. So when I say this word net present value, so this word itself includes this present value. That means it has the application of time value of money. Okay, that means we need to have the present value of cash flows, and we need to have the present value of cash inflow and outflow. Then we need to calculate the difference between these two so that we will get the net value of the present values that are available. So this is called net present value. It helps us in forecasting the cash flows of the investment project on realistic assumption. Why realistic? Because it includes the time value of money. It talks about the present value. For this very purpose, we need to have an appropriate rate of discount which may be identified to discount the forecasted cash flows value. That means we need a particular rate which may be used to convert the values into present value terms. And the appropriate discount rate is a project's opportunity cost of capital. So basically this appropriate rate that we are using for the purpose of discounting may be considered as opportunity cost of capital. And by using this discounted rate, we can convert the values of cash flow into present terms, and by deducting the present value of cash outflow from present value of all the cash inflows, we will get the value of NPV, that is net present value. And if we are evaluating a project and we are getting this net present value as positive, we are going to accept this project. And in case we are getting the negative value of NPV, we are going to reject the project. But what if we have more than one project to evaluate? So if we have more than one project, that means we have 2, 3 or 4 projects to evaluate. In that case, the project with the highest NPV will be ranked as 1, and similarly we will carry on. And when we are selecting between 2 projects, that means we are selecting between maybe mutually exclusive projects. So we are going to choose the project which has higher NPV. So this NPV can be calculated with the help of the formula which is visible on the screen. So in the first part of this equation, we can see that these are the cash inflows basically which are converted into present value term by using this rate, that is cost of capital, or we may also call it discounting rate. So it may be the cash inflow for the first time, then second year, in third year, and so on. We are going to convert all the cash inflows into present value terms, and we are going to take all inflows together. So when we are adding all the present values of inflow, we can write it in this way as summation of all the present values of cash inflows, out of which we need to deduct cash outflow. And by getting the net value, we are able to get the value of net present value. Let us see and understand this with the help of one example. We need to calculate NPV for an initial investment of rupees 2 lakh, which has a net cash inflow of rupees 60,000 annually for 6 years. So in this case, we are getting 60,000 annually. That means year after years for 6 continuous years. That means the cash inflow is same, equal year after year. Okay, we need to assume the cost of fund to be 8% here. So this is going to be our discount rate. And we need to suggest whether the project is acceptable or not on the basis of NPV. So we can solve this question by taking the cash inflow values, which is 60,000, and we are getting this for 6 years. Now, when we need to calculate the present value of this 60,000, we can use the concept of time value of money by using or by applying this PVAF, that means present value annuity factor. So the 60,000, because this is the repeated amount we are getting year after year, that means equal cash inflows. We need to multiply this amount with PVAF, and we can get this value of PVAF from the PVAF table, about which we talked in one of the session on time value of money, for which the link is provided on this screen here. Okay, you can always refer to this concept of time value of money from this link. So in this session, I talked about this, that how we can get the value of PVAF. So by following that method, we can get the value of PVAF from the table under the intersection cell of 8% and 6 years. The value that we got from the table is 4.623, and this value needs to be multiplied by 60,000, and this way we can get the present value of cash inflow, that is 2,77,380 rupees. We already have the cash inflow, that means the amount that we have invested, which is rupees 2 lakh. So what net present value says? We need to deduct present value of cash outflow from present value of cash inflows. So we can calculate net present value by deducting 2 lakh from 2,77,380. And by doing this, we get this value rupees 77,380, which is a positive value. Since we don't have any other project to compare with, and we need to take the decision for this particular project, and NPV for this particular project is positive, so we are going to accept this project. So this is how we can use the concept of NPV to decide whether to accept the project or to reject the project. So whenever we have positive NPV, and we need to judge only one project, and we have positive NPV, we are going to accept the project. And in case the NPV is negative, in that case, we are going to reject the project. We may see this one more example where the cash inflows that we are getting are not equal, or I can say these are unequal. So the question is visible on the screen. So we need to calculate NPV if the initial investment of rupees 10 lakh is there. Machine life is given as 5 years. The question is asking, is it feasible to buy the project? The cash flows and the years are given. It is available on the next slide. I'm sharing this with you all. The cost of capital that needs to be considered for this question is 10%, and we need to analyze this machine. So these are our cash flows. Under year 0, we can say the cash flow is given in brackets. That means this is the amount which is negative. That means this is our outflow. So this is 10 lakh rupees. That means our initial investment. Whereas these rows from 1, 2, 3, 4, 5, these are the cash inflows. The subsequent rows shows cash inflows. That is 2 lakh for first year, 2 lakh for second year, 3 lakh for third year, 3 lakh for fourth year, and 3,50,000 for fifth year. Now we are going to use this for the purpose of solving our question. How we can do this? So in previous case, when we have equal amount, we use the concept of PVAF. Now in this case, since we have different cash inflows, so we are not going to use annuity factor. In this case, we are going to use PVF. That means present value factor. Again, we can get the values of present value factor from this PVF table. And for that, you can refer to time value of money session. Here I just took the values from the question itself, the table values, okay, the values of cash flows. The PVF values are taken from the table, PVF table, okay, under the 10% column. Okay, so at 0 year the value is 1, but for first year the value is 0.909, for second year it's 0.826, for third year it's 0.721, for fourth year it's 0.683, for fifth year it is 621. These values are taken from the PVF table. We need to multiply these cash flows with PVF, the factor, to get the present value of individual cash flow. So in first case, it is minus 10 lakh only. In second case, when we multiply 2 lakh with 0.909, we get this value 1,81,800. In second case, when we multiply 2 lakh with 0.826, we get this value 1,65,200. Similarly, we will get these values. And when we are adding all these values, that means we are adding all the cash inflows and we are subtracting the cash outflow, because this column itself says these are present values. Now, by adding up all the present values of cash inflows and deducting the present value of cash outflow from this, we will get this value, which is known as our NPV, that is net present value, which is negative in our case, that is minus rupees 5,450. Now, based on this value, we can make our conclusion. So for this case, this particular example, we need to reject the project because NPV is negative rupees 5,450. And just in case after solving this, we got the positive value. Suppose this 5,450 is positive. In that case, we should accept the project. We should have accepted this project rather. Okay, so this is how we can use the concept of NPV for taking the decisions for accepting or rejecting the projects while considering long-term decisions. Another method that we have today is internal rate of return method. So it is, I can say it is related to the concept of NPV, and we will learn how the concept of NPV is applicable while dealing with internal rate of return. So what is internal rate of return? Internal rate of return is nothing but that rate of return at which our NPV becomes 0. That means it takes us to break-even point. This is the point where the firm is in a situation when it is neither suffering losses and nor getting profits. So I can formally say this, that internal rate of return is that rate of return that equates the investment outlay with the present value of cash inflows received after one period. So both the terms outflow and inflow are converted into present value. We are comparing these two values and the rate, the discounting rate that we have used for NPV, that discounting rate at which the present value of cash outflow and present value of cash inflow is equal, that missing rate, that rate is called internal rate of return. So this, according to this definition, it also implies that the rate of return, or I can say the discounting rate at which our NPV is 0, the rate which makes our NPV 0 is our internal rate of return. There is no change in the formula for calculation of internal rate of return. It can be calculated just the way we calculated net present value. But the only thing is, in this case, our net present value has to be 0. We need to calculate this missing R in case of internal rate of return. So according to definition, internal rate of return is that rate of return where the sum of all cash inflows, present value of all cash inflows, are equal to present value of cash outflow. We need to calculate, we need to find out this R, and this is our internal rate of return. Okay, this is something which makes our NPV 0. Okay, and wheresoever our R, our internal rate of return, is more than cost of capital, overall cost of capital, in this case we are going to accept the project. If our R is less than cost of capital, overall cost of capital, we are going to reject the project. We may accept the project or reject the project if our R is equal to K. Now let us understand this concept of IRR with the help of one example. Now a firm is evaluating a proposal and this project costs rupees 20 lakh and has equal cash inflow of rupees 5 lakh at the end of each of the next 6 years. There is no salvage value and the cutoff rate is 12%. We need to calculate IRR in this case. Okay. So the very first step that we need to follow for calculating IRR is, again, we need to calculate NPV. But at which rate we need to calculate NPV? For this, we need to follow trial and error method. That means we have to randomly pick any rate of discounting rate at which we need to calculate NPV, and we have to reach to at that discount rate, that rate at which our NPV will become 0. So I randomly picked 12% in this case. So I calculated NPV for 12%. So by multiplying 50,000 with PVAF factor, which is 4.111 in this case, 20 lakh is initial investment. And after deducting this 20 lakh from 20 lakh 55,500, I get NPV as positive 55,500. So at 12%, NPV is 55,500 positive amount. But we need to calculate R, we need to calculate our IRR, and IRR is that rate at which our NPV is 0. That means I need to increase this 12% amount, that the 12% discount rate, to that level which will make my NPV 0. So it is not happening at 12%. So the next rate I will pick here is 13%. Okay, again I will follow the same process and calculate NPV for 13% here. So 50,000, which is cash inflow, it has to be multiplied by PVAF for 13%. Okay, and I need to again subtract 20 lakh, which is initial investment here. So the amount that I will get after solving this is minus 100 rupees. Now in this case, the NPV will become negative. But again, I need that NPV, I need to make my NPV 0. I need that R. So my R will lie somewhere in between 12 and 13%, because at 12% my NPV is positive, but at 13% my NPV is becoming negative. So I need to find out where between 12 to 13% my IRR is lying. Okay. For that, I need to follow one step that is known as interpolation. Okay, I need to find out that range, that particular rate, that point, somewhere between 12 to 13%, which will make my NPV 0. So what I will do, I will take this minimum amount that I have taken under my trial and error method, that is 12% in our case. I will use this amount, the present value which I calculated in first case here, 20 lakh 55,500. I will deduct 20 lakh, which is initial cash outlay in this case. This amount has to be divided by, again, the cash inflow in case of 12%, total of cash inflow, and I have to subtract total of cash inflow in case of 13% from this. I need to multiply this with 1. Why? Because the range or the difference between the rates that I have taken for calculation of my NPV here is 1% only. So if I have taken, say, first calculation I did it for 12%, the second calculation it may be possible I may try for 15%. Okay, so in this case this amount will be 15 minus 12. Okay, so by interpolation, by solving this step, I got my answer, which is 12.98% in this case. This is what our NPV calculation also said, that our IRR is lying somewhere between 12 and 13%. But what is that somewhere? What is that exact point? We have reached to our exact point by doing this interpolation, and the exact IRR is 12.98%. That means 12.98% is that discount rate which will make my NPV 0. Okay, so this is how I can calculate my IRR. The third method that I'm going to discuss today is profitability index. Again, this is somehow similar to NPV. We are extracting the same values, same methods that we are using to calculate for NPV. Okay, but what is profitability index? Okay, as the word says, it is index. That means it is a ratio. Ratio between what? It is the ratio between present value of cash inflows at some required rate of return to initial cash outflow of the investment. Again, you can clearly relate this with NPV. Under NPV also, we need to calculate present value of cash inflows. In this case also, we need present value of cash inflows. When we are solving or we are doing calculation for NPV, what we do? We need to deduct cash outflow, present value of cash outflow from present value of cash inflow. But since this is the case in which we need to calculate ratio, so we need to calculate ratio by dividing present value of cash inflow, and we need to divide this present value of cash inflow with the present value of cash outflow to get the ratio which is known as profitability index. This may be presented in the form of formula like this. So our profitability index is present value of cash inflow, which has to be divided by initial cash outflow. And in equation form, again, summation of all the present values of cash inflows divided by, in case of NPV, we used to put minus sign here because we need to deduct cash outflow. But in case of profitability index, we are going to divide this with cash outflow. The acceptance rule is again same. We need to accept the project if PI is more than 1. We need to reject the project if PI is less than 1. We may accept or reject the project in case PI is equal to 1. Let us quickly try and understand the concept of PI with the help of this practical example. There is a computer A which costs 56,000 and we have computer B which costs rupees 60,000. The cash inflows again are given in the table which is given in the next slide. We need to calculate profitability index when the cost of capital is 10%. So these are the cash inflows of computer A and computer B for 5 years. Now let us solve this to calculate the value of profitability index and to give the conclusion for computer A and computer B. Again, for computer A, I took these values from the previous table from the question itself. Here 1, 2, 3, 4, 5. These are the cash inflows for computer A. 14,000 for first year, 16,000 for second year, 18,000 for third year, 20,000 for fourth year, and 25,000 for fifth year. Again, PV value at 10% rate. This is something we can always get from the PVF table. This is similar to what we used for NPV calculation. And we need to multiply 14,000 with the first value, that is 0.909, to get this value. And similarly, by multiplying these row-wise, we get these values, which are present values. Now, by adding these 5 values, we can get the total amount, that is 68,645. And PI formula says that we need to divide the present value of cash inflows by cash outflow. So the cost in case of computer A is 56,000. Now, by doing this, we get the value, that is PI value for computer A, which is 1.225. In the similar manner, we can do the calculation for computer B. We can get the values from the tables. That means cash inflows can be taken from the table, from the question itself. PVF values can be taken from the table itself. By multiplying the cash inflow value with PVF, we can get the present value. And by adding these values, we can get the present values, total of present values, total of cash inflows. And this total of cash inflows, that is 71,521, has to be divided by cash outflow. That means this is the cost of computer B. By doing this, we get this value, which is profitability index for computer B, that is 1.192. Okay, so in computer A, in case of computer A, the profitability index was 1.225, but in case of computer B, the profitability index is 1.192. So since the profitability index is higher in case of computer A, we are going to accept computer A in this case. But since the profitability index is positive in both the cases, in case of both the computers, so both the computers are acceptable. But in case we have to choose any one computer out of these, in that case, we are going to choose computer A because it has higher profitability index. So this is how we can make the decision when we are considering profitability index. In some books, there is one more evaluation criteria under discounting method techniques which is available, that is discounted payback method. This is similar to payback method that we already discussed under non-discounting techniques. with the only one small change, with the only one change that is under while calculating the payback period for non-discounting technique, we were using cash inflows as it is, whatever given to us. But when we are calculating payback period under discounting technique, or we are calculating discounted payback period, so all we need to do is we need to convert all inflows into present value term. That means we need to apply the concept of time value of money in this case to calculate discounted payback period. Otherwise, every calculation will remain absolutely same. Okay, so these are the four methods that can be considered while calculating or while taking capital budgeting decisions. So this is all from my side. Just to recap, the overall capital budgeting session included the meaning of capital budgeting, what we understood by this term. We discussed the features important of capital budgeting. In previous session, we discussed payback period method and accounting rate of return method under non-discounting technique. And in today's method, we learned about net present value, internal rate of return, profitability index, and we also talked about discounted payback method under capital budgeting techniques. So that is all from my side for today's session. See you very soon in the next session. Thank you and happy learning.
My